So today I've been working on this notebook. This is a model that predicts the likelihood of domestic violence using this data set here. So this is a data set on Kaggle, and it actually predicts based on different factors. So I'll just go to the as highlighted here. So the age, education, employment, income level, the marital status. So this is all here in this notebook. So I started by downloading the dataset, and I just saved it under my downloads page and access it using pandas. So I read the CSV, and this is actually what I have. So you have, for example, in the first row, the age is 30, education is secondary, unemployed, income level is 0, the marital status is married, the likelihood is yes. So it goes on and on for all the other values. So next, it's actually important to try and query the columns, because that's the only way you'll discover that things don't actually just look the way they seem. Because in this case, you look at an example of education, you realize that it has a space at the end. It was saved, the name of the column was saved with a space at the end. Same with employment, same with marital status and violence. So to access, so in that case, if I were to access the value of violence, let me just I can just do it over again. There's no problem. So let me just try and insert a cell below, and just to demonstrate. So if I were to access the value of violence as an example, if I just write it this way, it will give you an error and tell you that violence doesn't exist. So the reason why it's important to query, to make these queries so that you can see such instances. So if I were to add a space at the front, I get the values of violence. So that's how it is. So next, because I'm trying to predict the likelihood of violence, and I have this, there are some columns here that have, they are not numerical, they have categorical values. So these are what I have to convert to numerical values using, so in this case I used one-hot encoding from sklearn, just to help me convert education, employment, and marital status to numerical values. So this is what I did here. I started by importing one-hot encoder, and then try and get the categorical values. So from my data frame, so these are the categorical values. And then I initialized the encoder and used it to transform the categorical values, which I later converted into a data frame, and this is what I got. Maybe I can just spend a minute to explain the whole idea of one-hot encoding. The only thing we are doing in one-hot encoding is trying to, let me just use this example. Let me use this row. So the violence, the instance, what we do with one-hot encoding is just to increase the dimensions of the data. And the reason why we increase the dimensions of the data is because we are trying to break the data into many categories based on the values that are there. So in this case, the values under violence, under violence, we have two values, two possibilities. So it's either yes or no. So if you break violence into two columns, then you can just say violence no, violence underscore no, and then for the first one it will be 0, the second one it will be 1, the third one it will be 1. So Where there is 1, it's a no. Where there is 0, it's a yes. That's what we are doing. But then the idea of how one-hot encoding approaches the problem is by separating now this column into two. So you'll have violence underscore no and then violence underscore yes. Let's look at how it was handled. So this is what I'm referring to. So for the first one, you can see violence underscore no is 0.0 and violence underscore yes is 1.0. So for the second instance, since it was a no, it's 1.0, 1.0, 1.0. So since we are working with a binary value, which is either a 0 or a 1, that means that we can as well just work with one column and then assume that anytime I get the value of 0, that's a yes. That's a possibility of violence. So by reducing the dimension, you'll be simplifying, you'll be saving on the computation. It will also help in preventing, aid in preventing overfitting. So this is what happens with the two, and we'll see how I approached it because this is now the violence is the target in this case. So it's the same concept for all the other features. For example, marital status, it has been divided into two. There is the married and unmarried. This is also something that can be changed, but I didn't actually change this. I didn't change the marital status. The only change I made was on violence. And it's the same thing with employment. So there are categories of employment. You can either be unemployed, semi-employed, or employed. And then there is also the education. So if it's primary, it's 0, it's secondary. So once it's more than 2, then there is actually no need of breaking it. But then if it's just 2, for example, marital status, that one you can drop one column just to you can just reduce the number of dimensions to make it simpler. So that's what I did. In this case, there were 12 columns. So I actually just concatenated the initial data frame with this one hot encoded data frame, and then I dropped all the columns that had the categorical values, and then I ended up with this. This updated table. So I also dropped the serial number. This was the first column here. I dropped it because I don't really need the serial number for the training. And then you can see the shape here, and then I retrieved all the features so that I can initialize them to variable x. So you can see this is the x, and then I also got the target variables to y. So in this case I just used violence underscore no. So the idea is like anytime I get a 0, that's a yes. Anytime I get a 1, that's a no. So as you can see, that's what I did there for the y. And then I split using trend test split from skline.model underscore selection. I just split the data set into 4, with each pair being training and the other pair for testing. So you can see the shape of X train, X test, Y train, and Y test. And then for this particular problem, since it's just a simple classification task, I used logistic regression for it. So I initialized the model and then fit the model on the training data, and tried to make a prediction. ESP, here is the retrieval of the first 5 values, which are all no's, 1. Remember what I did with the value of y. So these are all 1s. And then for the for the test set now to check the accuracy. For the first 5 it was all okay, it was all a no, and then I tried to check the accuracy and it is 72%, which is not bad. So this is how I approached this problem. It's a very interesting problem, and I'll be doing a number of this problem. Yeah, I'll be doing a number of this problem, and when I get time I will always try to either write an article about it, or I can just make a very short video to talk about it, so that people can learn one or two things of how I approach these problems in machine learning. So thank you.